All right, how are we doing? It's Wednesday, right? What homework questions do you have? Yes?
Finding the horizontal asymptote. I keep moving the train of thought. So you divide out the bottom and like you plot all the factors and you go out on the top. But then what do you do from there?
Okay, so like if you want to figure out what the horizontal asymptotes are. Okay, so that's actually the whole next section is also based on that. And so we'll do a lot of practice on it today. And so hopefully that will clear it up. Pretty much every question on this section asks you what's the equation of horizontal asymptote or oblique asymptotes if you have them. So, but we can, if it doesn't answer what you're doing in 3.4, then we'll probably have time to go back and look at those too. Yeah, great. Other questions? Okay. So 3.5 is all about graphing rational functions, which is really just a continuation of what we were doing yesterday, right? This one's going to focus a little bit more on just taking the function, right, in this rational expression and building the graph yourself, right? And so it seems like in the last section, some of the time we were given the graph. Now we're going to have to build it ourselves. Okay, so there are, four parts that most of these questions are going to ask. They'll ask for the domain, the equation of the vertical asymptotes, the horizontal asymptote or oblique asymptote, and then they ask you to identify the graph of the function. So personally, I think it's kind of out of order the way that they've asked them because you want to compute vertical asymptotes and then that will help you determine the domain, right? And so let's start with an example here and then we'll move into more, I guess, challenging examples. But one thing that we want to focus on here is this relationship of the highest degree in the numerator with the highest degree in the denominator and what that does with horizontal and oblique asymptotes, okay? So on this first one, I'm going to kind of skip part A and work out part B first. So the vertical asymptotes, where are we going to find those?
X equals -2.
Okay, so how'd you get it?
If you multiply 5 by -2 and then add into it, you're going to get 0 on the denominator.
Okay, good. Yeah, so you can figure out where those will be by setting the denominator equal to 0. And you got x equals -2 out of that. Good. And then what we're going to have to do then is double check that that doesn't also make the numerator 0, right? Which here it doesn't. Okay, if it also made the numerator 0, then what you have could be just like a hole in the graph instead of a vertical asymptote, right? And so right now we're not really dealing with that situation, but it's good practice to go back and just double check that you're getting something non-zero in the numerator when you plug that in, and then you'll have a vertical asymptote there. Okay, so now that we know we have a vertical asymptote there, right, where the denominator equals 0, those are the only places that are not going to be allowed in the domain, right? And so now we can answer part A. Let's see. So part A, we can say that the domain is, and I think in this section they write it as x such that x is not equal to -2. And then we can answer B. Equation of vertical asymptotes was x equals -2. Is that vertical line? Okay, and then part C, it's asking for horizontal asymptote or oblique asymptote. So where we had our original function equal to what it was, 6x plus 6 over 5x plus 10. Okay, we have three situations that could come up here, right? You have when the highest power is the same, like we have in this case, on the top and the bottom. If the highest power on the bottom is larger than on the top, that's one other case. And then if the highest power on the top is one larger than highest power on the bottom, that's the last case, right? So let's just kind of summarize the three things that are going to come up here. Okay, so if the highest power on the top and bottom are the same, then you're going to have a horizontal asymptote. And how did we find it in that case? As x gets really large, right, the top and the bottom are kind of growing at a similar rate, right? Whereas the 6 and the 10, they're going to stop really mattering as x gets huge, right? They're not going to make much of a difference. And so we can just sort of ignore everything except the highest power term. Right, and we could say that we can get that horizontal asymptote, right, by saying what we're going to take 6x we're just going to ignore what's going on with powers lower than the highest one and say that this is going to go to it's going to go to start looking just more and more like 6x over 5x as x gets really large, or 6/5, right? And so you're going to say that you have a horizontal asymptote at y equals 6/5, at that height of 6/5. Okay, so as x gets really large to the right or really large in the negative direction, then it's going to approach just this ratio of the two coefficients on the highest power. That happens when the highest power on top and bottom are the same, right? So that's one situation. Another situation would be that the highest power on the bottom is larger. And so in that case, the denominator is going to grow faster than the numerator, and you end up with a horizontal asymptote always at a height of 0. And then the last case would be that we're considering here would be highest power on the top is 1 more than in the denominator. And so in that case, you get an oblique asymptote, and you find it using division. Okay, so those are the three cases that are going to come up in this section. If You could also, theoretically, you could have, a highest power more than one larger on the top, and then in that case, you don't have a horizontal or oblique asymptote. Okay. So those are our three situations that are going to come up in the questions in this section with the horizontal asymptote. And then, let's see, what else were we supposed to find in this one? We're supposed to sketch a graph of the function. So, and in the homework, that will mean you need to pick the correct graph. So what we can do is draw our asymptotes to start out with, give ourselves a template. So we have a horizontal asymptote at 6/5. So we have our height of 6/5 here. We have a vertical asymptote at x equals -2. All right. So we can get a pretty good picture of what's going on if we look at what's happening as we approach -2 from the left and the right here. First off, we need to figure out on this side of our vertical asymptote, should I be above or below 6/5? And so I could just plug in a value, say -3, for example. And if I did, what would I get here? I'd get -12 over -20, is that right? No, 3 -5. So -12/5, is that right?
No, they're both negative.
Oh, they're both negative, that's right, positive 12/5. So we're up above, right? Okay, so we're up above, and then as we approach -2, then are we going, the question now is going to be, are we going up or down along that asymptote? If I take values close to -2, but on the left, so slightly less than -2, right? What's going to be happening? I'll definitely have a number that's approaching 0 in the denominator that's negative, right? And my numerator will also be negative, so I will be having numbers that are shooting up, I think, right? Along that asymptote. Now, to the right of that, we could do the same sort of thing. Easiest one here to plug in might be 0, and when we do, we get, 6/10, which is less than 6/5. Okay, so we're going to end up with, we're down below this asymptote, we're going to be something like that. So we'll look for that picture. We don't really need any more information than that. Right, probably on this one to go look at the pictures and find which one it matches. How are we feeling? Makes sense? Cool. All right, let's look at the next one. So this one says analyze the graph. Looking at this, what type of asymptote will we have? Horizontal or oblique? Oblique, yeah, the power on the top is one higher than the bottom, so we know we're going to have an oblique asymptote. What about vertical asymptotes?
That's 6 and -6.
Okay, good. So if you say x squared minus 36 equal to 0, we'll get x equals plus or minus 6 for our vertical asymptotes. And so when it asks us for the domain, sorry, let me, how do I put, yeah. Since I'm recording this, I've got messages showing up on this, so I'm trying to put it on Do Not Disturb. Okay, so we have plus or minus 6. The domain is going to be everything except those two values, right? Okay, so we have two vertical asymptotes. Now let's come up with our oblique asymptote. All right, so how did we do that again? Okay, so we have this, and then we're going to take x squared minus 36. We're going to divide, so we're going to have x. We need to multiply this by x to get this leading term. Okay, and so we'll get x cubed here, and then minus 36x. And then I need to remember to subtract that. And so now I'm going to get, what, minus 36x. I'll bring down the minus 125. That means I need to multiply. Okay, so let's see. What can I do now? I need to look and see, is there anything I can multiply x squared by a polynomial to get minus 36x? And I can't, right? So that's going to be my remainder. Okay. All right, so what does that tell us about our slant asymptote? We're going to have, we can rewrite our function, h of x, as just x plus, and then we were not able to divide minus 36x minus 125, and so we have to write it still like this. So our remainder over what we were dividing by. But as x gets really large, to the right or to the left, what's happening to this piece?
Down.
Yeah, the power on the denominator here is larger, and this is always what happens when you divide, right? When you split it up, the power on the top will always be less when you're finished, and so this is always going to be going to 0 as x gets really large. And so we would say that our oblique asymptote would just be y of x, or sorry, y equals x. This is the part that it's going to be approaching. It's going to just look like x. As x gets really large, this is going to be really close to 0, and so we're just going to be approaching the height of x.
Sorry, but is this positive 36 negative?
Oh, I better double check, huh?
This is positive.
So, oh, right here. I should not have had a negative.
Positive.
Yeah, thank you. Good catch. There we go. Does that look better? Okay, questions on that? All right, and then what else did it ask for on these? It was, just make a graph of the function. Okay, so now what we need to do is we'll draw our vertical asymptotes. Those were where? -6 and 6? And then we have our oblique asymptote is the line y equals x, so that's just going to look like that. Right, and then in each of these sections, in between the vertical asymptotes, we just need to figure out what's happening, right? And so what's happening to the left of -6? Let's discuss that first. It looks to me like you're going to have a -6, or something smaller than -6 here. That's going to make this is negative in the top, right? Large negative, fairly large negative number, and then you're going to have something a little bit larger than 36 minus 36, and so you would have a fairly large negative number over a number that's approaching 0 from the right. It's positive, right? So I think we're going to be down here our graph is going to look something like that down here, right? What about in between those two? Here we could try plugging in 0 and see what we get, right? So if you plug in 0, you're going to get a positive number, 125 over 36. So you're going to have a point somewhere here, and as you go to the left and to the right, you need to go along the asymptotes. So, well, maybe I'll draw it farther down, but it's gonna go, up along that one, I think. Let's double check. So as you go to the right from 0, you have positive numbers that are, as you approach 6, the denominator is going to get close to 0, but be negative. The numerator will be negative. So we'll be going up along that. The other direction, the same thing. Is this analysis that I'm doing on these making sense? Where I'm trying to see which direction it goes on the asymptotes?
Yeah,
Kind of, yeah.
plugging in numbers. See where it goes.
Yeah. So what about to the right of 6? Are we going to be up above or below that slant asymptote?
Below.
Yeah, because you're going to have, You're going to have the numerator, as you go to the right, 6 cubed is already bigger than 125, right? And so this is always going to be positive over there. This is always going to be positive over there, is it not?
That checks out.
Okay. So where is it going to be? What if you plug in like 6.1, for example? What's going to happen? Who's going to do that for us?
It's about 84.3.
Yeah, the denominator is going to 0 but positive, right? The numerator is going to some positive number. So yeah, it should be up above here. So it seems like it's going to look something like that, right? Okay. So then you'd be looking in the graphs that they've given you for something that looks like that. I'm concerned though about this middle one. Let's double check. As I approach, say, -6 from the right, I'm going to have a negative number in the denominator. Yeah, and a negative number in the numerator. I think we're good. Oh wait, no, negative and negative. Yeah, we're good. Okay. Let's see, before we do this next one, let me just make sure there's not anything, not any topic we're missing if we don't get to all of these. Yeah, I think, so I guess the one situation that we haven't looked at yet today would be something like this one. Right. So we'll look at what's the domain. So we need to set the denominator equal to 0. Right, so to get the vertical asymptotes in the domain. So you have x minus 10, x squared minus 25 equals 0. So either x equals 10, or what are the other two possibilities? X equals, 5 or yeah, so you would get 5 or negative 5 from this one. And so those are our three values. The numerator is never 0, so all three of these are going to be vertical asymptotes. Right, and so then we can say that the domain is all values of x except for those. Okay. Is this going to have a horizontal asymptote, oblique asymptote?
The horizontal asymptote around 0.
Okay, good. So it's going to be the horizontal asymptote at x equals 0 because, excuse me, or y equals 0, I mean, because the degree in the denominator is larger than the degree in the numerator, right? So that was the case where we have a horizontal asymptote at a height of 0. Okay, so now we could, let's draw what our function looks like then. So we have x equals 10, 5, and negative 5. Vertical asymptotes, and then we're going to have a horizontal asymptote right there at a height of 0. And then we just need to figure out in these 4 zones, right, where does our graph lie? So this is negative 5, 0, 5, 10. So to the left of negative 5, what's going to happen? This is negative, right? This is going to be positive. So we have a positive over a negative. Whoops. So we're going to be down below. At 0, what do we get? Is our graph positive or negative there?
It's going to be negative.
So you have, in the denominator, you're going to have negative 10 times negative 25. So we'll end up with a positive value. So something like that. As you approach negative 5, right, this is going to be, let's double check that though. As you approach negative 5 from the right, you have numbers like 4.9. This is going to be negative. That's negative, and so we're positive there. Okay, but now let's check 5 to see if we're really going to be above or if we're going to, so we know we never cross the x-axis, right? So I guess we can use that to say we're not going to go down below, right? We're going to have to stay above. All right, now what about greater than 5 but less than 10?
It's below the 0 point.
Okay, right, because you're going to get what? This is negative, this is positive, so it's overall negative. And then what about that last zone, greater than 10? It'll be back above, so it's going to just kind of flip back and forth like that. Okay. How are you feeling about these?
This one thing is about the last example.
The what, sorry?
This one thing is about the last example. Can you turn the page?
About the last example?
Yeah.
The previous one, this one?
Yes, this one. When the x coming next to the 6,
Uh-huh.
it's gonna be going down. You
Let's walk through and see why.
Yeah.
Okay.
Either one.
Yeah, so, at the positive 6, we got this part wrong?
Yeah.
Okay, so yeah, let's double check it. So we're looking at x, okay, so let's say as x is approaching 6 from the left, so like 5.9 for example, you're gonna get positive, positive over negative.
This is negative.
Yeah, thank you. Yeah, so this positive over negative, so this one's actually gonna cross down
Yeah.
like that. Yeah. Oh, good catch. So it's actually going to go maybe something, it's probably going to look something more like that, right? Okay. That looks more like a natural graph. Yes?
And what about x equals like 1? What is that? Where it goes to the oblique asymptote?
Yeah, so where should it be crossing the x-axis? Is that what you're asking? Yeah, so we would set the numerator equal to 0. So we could say x-intercept, right? The question doesn't ask for it, but it'll be useful here, right, to see where that crosses. So you have, you set the numerator equal to 0, and the numerator was what? Where are we? X cubed minus 125. So x cubed equals 125. What's the real solution to that? 5. Yeah, so my picture is not great, but yeah, it should be crossing at 5. So it's still in between 0 and 6.
No, I mean, how can it go to the oblique asymptote if it's a curved line there?
Oh, so horizontal and oblique asymptotes, your graph can cross them. Yeah, vertical it can't, right? Yeah, so what a horizontal or oblique asymptote is telling you is just as you get really far to the right or to the left, what is your graph approaching, right? But there's nothing that says that in the middle, you can't go across it. Yeah. So it's a little different than vertical asymptotes, because vertical asymptotes, your function is not defined there, you're never going to cross them. Yeah. I'm glad you brought that up. Yeah. This might be the first one where we've seen that behavior. Yeah. Okay. Has this answered your question about horizontal asymptotes? Like, is this making it clear? Okay, good. Let's look at this example here. We have x squared over x squared plus x minus 72. What about vertical asymptotes here? We're going to go ahead and set the denominator equal to 0, right? I think is that factorable? I think it's factorable. 9 times 8, I think, is what gives you 72. So if I have a positive 9 and a minus 8,
Flip the signs.
I flipped the order and not the signs, huh? You have minus 9 and 8. Okay, so we have our two vertical asymptotes. What about I guess the domain is what they want next. And so it's all the values of x. So the x is not equal to either of those. And then what about horizontal or oblique asymptote?
Highest powers divide themselves.
Good. Yeah, since the highest powers are the same, I can take the coefficients of those, which are both 1s, right? And so I'm going to get 1 over 1. So everybody's seeing how you get that? Okay, so we have a horizontal asymptote. We have 2 vertical asymptotes. We can draw kind of the template for our graph here. So here at -9, we're going to have a vertical one. At x equals 8, we'll have another vertical one. And then horizontal at the height of 1. And then we have to just walk through carefully, more careful than I did on that last one, to make sure that we recognize which direction it's going, right, along the asymptotes. Okay, so when we're to the left of -9, it might be easier if we actually write this out now factored as x plus 9, x minus 8. Because when we're less than -9, we're going to have, this is negative, right? And this is negative. The top is always positive. And so we're going to be above. Is everybody okay with that so far? Now, a little bigger than -9. This is now going to be positive. This is still negative. And so we're going to be negative along this axis, or along this asymptote. And then we need to see if we go up or down along this one, right? We could possibly cross. In fact, do we have we could go ahead and say what our x-intercept is on this one. 0. So we know we're going to hit 0 here. It's going to hit this 0 at some point. And then we just need to see, are we headed up or down from there? So if we plug in, for example, 7.9, this is positive and this is negative. So it looks like we're going back down, right? Looks like that. And then, but it did touch that axis, right? And then to the right, we have everything's positive after that. So we'll be up above again. All right. We okay? What do you want to do? We could do more examples. This whole section is just these, right? It's just practicing these. More of these. Everybody's really opinionated about it. Hang in there, I know. Middle of the week, it's rough. All right, well, if you're all feeling okay about it, let's go ahead and stop there for today. Tomorrow, we'll go ahead and move on to the next section, but please, if you have questions about any of this, feel free to bring them. We'll talk about your questions as well, okay? You bet.